Most of the websites today are running based on chatbots. So, what is the key technology beside that? SLM models. So, SLM today is a trending AI technology that is useful for building many businesses. So, using these SLMs, so many companies are earning much more profits than usual. But what is happening inside those SLMs? In this video, we are going to see very clearly how internal structure of every SLM models looks like. Think of it like a mini brain for text, designed to be super efficient and smart, but without needing to be as massive as those huge AI models you might have heard about. Imagine you want to teach a computer to understand and generate text, but you want it to be quick, focused, and not to take up a ton of space. That is where SLMs work and they come in. They are built on the same core ideas as bigger models, but with clever shortcuts to keep them compact. Let's break down how it works step by step using our diagram. First, we have the tokenization layer. This is like teaching our mini brain its ABCs. When you give it a sentence, say hello world, it doesn't see as one big string of letters. Instead, it breaks it down into smaller, meaningful pieces called tokens. These can be words, parts of words, or even punctuation. SLMs often use specialized tokenizers, meaning they only learn the vocabulary relevant to their specific job. Maybe medical terms for healthcare SLM or common phrases for a customer service chatbot. Once we have our tokens, they move to embeddings. Here, each token gets turned into a special code or vector. Think of it like giving each word a unique set of coordinates in a map of meaning. Words that mean similar things will be close together on this map. For SLMs, these maps are smaller and more focused again, specialized for their particular domain. A healthcare SLM's map will be very good at distinguishing between different medical conditions, for example. Once we have our tokens, they move to embeddings. Within each block, there are two key mechanisms. Self attention is the first mechanism. This is super clever. It is how the model figures out which words in a sentence are most important to each other. For instance, in the quick brown fox jumps over the lazy dog, fox and jumps are closely related. Self attention helps the model understand these relationships, no matter how far apart the words are. Feed forward neural network is a second mechanism. After attention identifies those connections, this part processes and refines those insights, turning them into richer, more complex patterns for understanding. In SLMs, we have fewer of these transformer blocks and simpler attention mechanisms compared to bigger models. That's what makes them lighter and faster. Now, how do we keep these models so small and efficient? That brings us to parameter reduction techniques. Here are three main strategies. Pruning is the first strategy. Imagine a vast garden with some plants that are not really doing anything. Pruning is like cutting out those unnecessary connections or neurons in the model that are not contributing much. This is like removing unwanted applications from laptop that are not useful anymore. So it saves so many space. At the same time, it speeds up the computer right. This makes the model leaner here. The second strategy is quantization. Computers usually use very precise numbers. Quantization is like simplifying those numbers, using less details to store them. It is like going from a high resolution photo to a slightly lower resolution one. You save space and it often doesn't affect the overall quality for the task at hand. The third strategy is distillation. This is a cool one. Imagine you have a super smart but huge teacher model. You train a smaller student model to learn directly from the teacher's answers and reasoning, effectively mimicking the bigger model's intelligence without needing all its complexity. Finally, we reach the output layer. After all that processing, the model takes its refined understanding and converts those mathematical representations back into human readable text. This is where it generates its predictions or responses, like completing your sentence or answering your question. So, in a sense, an SLM takes text, breaks it down, understands the relationships between words in a focused way, learns efficiently through clever reduction techniques, and then generates new text or insights. It is a powerful and practical form of AI, bringing sophisticated language understanding to specific tasks without the massive computational cost of its larger cousins like LLMs.